The RGB parade scope is useful when you're working with red, green, and blue color channels, but it is kind of a confusing scope because it combines chroma and luma into one scope. And there's a great deal of misunderstanding about how it works. So I'm going to try to set the record straight in this lesson. To follow along, go to Working Files, go to Premiere Pro Projects, and open up Parade Scopes. Now I want you to look at the beginning of this clip down here, the YCBCR example clip, because farther into the clip I move it around a bit. You see that? I want to stick with this one on top here. This is an image from Wikipedia. I'll show you the full image here by going to the project panel and double-clicking on it. That's how it looks. Long strip here showing what's called YCBCR. And we'll talk about this in a separate lesson. All right, let me go back to the reference monitor there. I have the reference monitor opened up to the RGB Parade. To get there, you go to the panel menu and go down here to RGB Parade, like that. What we're seeing here is sort of like the waveform scope divided into 3 areas. Each of these things shows this image left to right. So from here to there, that's the red channel of this image. Here to here is the green channel of this whole image. And here to here is the blue channel of this whole image. Television sets and monitors display colors using red, green, and blue dots, which match the receptors in our eyes. In reality, most video is not stored this way. Video is stored using another method called YCBCR, which I discuss later. Nevertheless, it's converted to RGB for display on your computer monitors or on television sets. And so sometimes you want to work in individual channels when you're doing your color correction. And so the RGB Parade scope is the scope that you use when you do that. So to get a sense of how this works, let me shift over to the waveform monitor for a second. Go up to here, go down to the waveform. And you see left to right how this image works. The black on the sides here equals this black over here. Then you see those bright areas up here, that's the snow. Here's the blue sky, and this is the grass, and this area is the mountains there. And these areas, these dark areas right there, like that. It's similar now in the RGB Parade. I'll go over here, RGB Parade, and it's similar. You see how it's got that same kind of a setup with the bright snow, and the blue sky, and other elements like that. But you see that the blue sky here is not much red in it, some green, but a lot of blue in it, as you'd expect. That's what this guy is showing. Not just left to right with luma, it's left to right luma and chroma. But as I said, this can be a little bit confusing when you're working with this scope. So I'm going to walk you through it a bit here by going to this first clip, this gray solid like that. You need to look really carefully, but here in the RGB Parade, you've got 50% red, 50% green, and 50% blue. Those 3 colors combined create 50% gray. That's how that works. If I turn on the fast color corrector here, and change the color, I'm going to add red. Notice that the red goes up and the green and the blue go down. So by adding red here in this color wheel, I'm actually removing green and blue. Now it looks like I've increased luma of red here, but in fact I've just increased the amount of chroma, not the amount of luma. But the RGB Parade makes it look like I've increased luma. That's one thing about the RGB Parade. I've just increased chroma here with this color wheel, but this thing went up as if I increased the luma here. The 2 things combined, it is kind of hard to distinguish between one and the other. So basically what this is showing you is kind of color values. All right, let me go on to this next one here, this gray solid. You see how we work there. To get white, we have 100% red, 100% green, and then 100% blue, which you can barely see there, but there's a blue line there. And then to get black, I get 0% red, green, and blue. That's the black down here in the corner. If I apply the fast color corrector to this one and change its hue, its chroma, I'll lift its red up. Notice the red values go up now. No dark area of red anymore, but the greens and the blues get darker. At least that's what it looks like there. But what you're really doing is you're adding red hue, red chroma, and removing green and blue chroma and hue. All right, let me just move on down the line a little bit farther here. You see how this works. Left to right there, that's the red value, up to the top and dropping down, green and blue. Same thing with the bars and tone. This gradient is this line right there, or these lines. This bright gray there is 75% gray, indicated by the 75% red, green, and blue. So I think you're getting a sense of how this works. All right, I'm going to jump ahead to RGB bars here. This is just the title that I created. I'll double click on that to show you the titler here. Just 3 bars there. If I click on one, you'll see that it's a gradient. It goes from red to black. Close that down. And you look at the RGB Parade here, and it looks for all the world like you've got 100 IRE to 0 IRE for red and green and blue. And notice how this works is the red bar there on the left with nothing next to it. That's because this is pure red, and there's no red in these other guys, green and blue. And the green is in the center with things on the left and the right-hand side where there's no green. And blue's on the right there where there's things on the left there where there's no blue. That's how that works. And it does look like it goes from 0 luma to 100 luma here, from black down here to bright white up here, but it doesn't really do that. It's just showing you this sort of amount of color thing that goes on with the RGB parade. If I switch over to the YC waveform, which does show luma and only luma, look at that. The green is much brighter, much more luma than the red, and a heck of a lot more luma than the blue. So this is our perception. We perceive these guys as being equally bright, and the RGB parade shows us that. It shows us our perception of the color based upon color and luma combined. But the actual luma is distinctly different for each color. Green is much brighter than blue. I'm going to show you what happens when you work with a fast color corrector here and also something called RGB curves. We'll get to that in a second. Click on fast color corrector here. Notice what happens when I turn on fast color corrector. You get this banding. It's something that you shouldn't get when you apply an effect, but that happens with the fast color corrector and a few other ones that have what are called levels style controls, these guys here. It's an unfortunate thing, but it doesn't seem to have much of an effect, if any, on images like this. But it can cause things to kind of break up in terms of the amount of luma for various elements inside your clip. But right now it doesn't show up here, so I think we're okay. But what I want to do now is change the chroma, so I'm going to lift up the red. And notice how that adds red all the way across the board down here in the dark areas as well. And it does lift up the dark areas, meaning that they're no longer black. They now have some brightness to them. If I change over to the RGB parade, it'll look much different. It's lifting red a lot and then dropping green and blue quite a bit in the brightness levels in terms of how we perceive the brightness of the color. But the actual luma, back here to the waveform, really hasn't changed much, except for the blacks being not quite so black anymore. I'll show you how this is different, though, when you use the RGB curves, which is the effect that you'll probably use when you use the RGB parade. So I'll turn off the fast color corrector here. Go to RGB curves, which looks like this, and we'll work with this effect a few times during this course. I'm going to add red here. Notice that it affects only red. It does not affect other colors. And there's a real misunderstanding about RGB curves. People think that when you add red, you're taking away blue and green, but you're not. You're just adding or taking away red. Like so. If I drop the brightness down, it affects only red, not green and blue. If I take the green down, it affects only green. This is in the YC waveform. Let's take a look at it inside the RGB parade. I'll bring the red down. And notice that only the red is affected, not the green or the blue. All right, let's take a look at this last one here. This shows all the various complementary colors. You've got the primary colors, red, green, and blue. And you've got the complementary colors, the magenta, cyan, and yellow. Magenta is a combination of red and blue. Cyan is a combination of blue and green. And yellow is a combination of green and red. Notice how the bars look here inside the RGB parade. Red is the one on the left there. The second one over is magenta, so it's a combination of red and this blue bar there. Notice the last red bar, the sixth bar there, is yellow, because yellow is red and green. All right, so that's how that works. If I go over to the fast color corrector again, and I add red, adding red takes out green and blue. So if I add red, it's going to make magenta less magenta and more red. And it'll make yellow less yellow and more red. If I go to the RGB curves instead, turn that on, add some red. It's going to take the magenta, make the magenta less blue and more red, and make the yellow less greenish yellow and more red. Take red out, I will make the yellow more green. So when I've got these other colors, these complementary colors, removing red also affects them as well. So it's not just red that goes away, it's the red part of the other colors that goes away when I use these controls like this. Add more blue, that'll sort of overwhelm the items that are blue, meaning the magenta and the cyan. More like blue and less like magenta or cyan. If I take blue out, it'll make those guys more like red and more like green. Working with the RGB parade is something we are not going to do all that often inside Premiere Pro because we're going to rely on the vector scope for color and the waveform scope for luma. But when you work inside SpeedGrade, your RGB parade scope is your go-to tool because the color tools inside SpeedGrade affect both color and luma at the same time. So you need to have an RGB parade scope to see what's happening when you're working with the color tools in SpeedGrade. So we're going to come back to the RGB parade scope quite a bit when we start working inside SpeedGrade.